All right, so yesterday we did a couple examples of applications of exponential growth, and today we're just doing the same thing, but with exponential decay. So I'm just going to define what exponential decay is. It's when a quantity decreases by a fixed rate. I'm going to put even in brackets or like percentage over time. So in our warm up, the amount of milk that Steven drank, it doubled every 5 minutes. It increased by a fixed rate over time. The Board's bank account, it increased by 4% every year. It's a fixed rate, 4% every year. So now we're just going to look at examples where things decrease in value. So nothing will really change much from yesterday. Let's dive into an example. All right. Oh no, bottle kids have ruined Julian's old car by throwing some empty bottles at it. It's done. He needs a new car, so he buys a 1990 Monte Carlo for $5,000. Now, most things like cars, furniture, go down in value over time. It's not like a bank account, an investment. They don't grow over time. Some things go up over time, like usually properties or homes or buildings, stuff like that, but usually not cars. So the value of Julian's car is going to go down in value by 15% each year. So let's make a model. Now I'll use V of t. I know it says V equals there. I'll use V of t. V, we'll just say V for value. You can use whatever variable you want. It should make sense. And t here is time, but this question, it's in years. I think everybody here is getting really comfortable picking off initial values. So obviously, initially the car is worth $5,000, and it goes down by 50% every 1 year. So in our exponent, we'll just have t. It's not t divided by anything. It's just every 1 year. But the question is, what are we going to put in the brackets to represent decreasing in value by 15% each year? I'm going to let you guys have a little think on that. I'm going to actually do my attendance. Just chew on it. Don't shout out an answer. Just chew on it for a second, and we'll see what you guys think afterwards. So I'm going to make sure to pause the video here. Zoom. So far, you guys have thrown out 0.15. That's not it. 1.15 was the closest we came. That's not it either. Negative 0.15 for decreasing wasn't a bad idea, but that's not it either. Anybody have any other ideas? So that would still be over 1, and that would mean it's increasing over time. So it's not that either. I'm going to go over here. So if our car goes down in value by 15% each year, then at the end of the year, it's not worth what it was. We take 100% of what it was worth and subtract 15%. So it's now worth 85% of what it was. To get the value of the car after a year, you multiply by 0.85. 85%. Why 85%? Because it went down by 15%. So you guys should have this calculation off to the side here. And so this is how we handle any question involving depreciation with something going down by a fixed percentage. You guys okay with that?
Yes.
All right. Said no burping. I'm recording this video to put on YouTube. It doesn't matter. It doesn't matter. I was going to pause and go on a rant, but I think I'll keep the rant in my back pocket. How much will the car be worth in 5 years? So now we can do V of 5. Over how much is the car worth after 5 years? Let's have a look. 5,000 times 0.85 to the power of 5. So in 5 years, 2,218 53. So nothing has really changed from yesterday. It's just our base will be between 0 and 1. And yeah, so what through part 3 is just the same. It's another plug and play. This time is just 2.5 years. So I imagine we'll be somewhere between 5,000 and the value we just got. Yeah, making the model is the most complicated thing, if you want to call it complicated. Now that you guys know that rule, it shouldn't be too bad. If I were you guys, I'd ask for questions like these all the live long day on our unit test. All right. 3,330.56 and 2.5 years. You people taking accounting, you guys do depreciation yet? Yeah, so this is one way to do depreciation. The other way of doing depreciation is where you like assume it loses a fixed amount every year and until it is worth nothing. But I digress. We're not in accounting class. All right, can you guys try the next one? You've got some information about a population decline in this case. So here we don't have a population that's growing. Here the population of mice is decreasing because we've introduced some cats into the trailer park. So can you guys look for some information in the question? You guys have those 3 blanks to fill in. Question should give you all 3. And then part 2, we'll just do something with the equation we cook up. Maybe we'll get somebody who hasn't helped out yet today to give us their equation. People who are watching at home, maybe pause the video and try to create the model on your own. All right. Anyone think they got the model here? Mackenzie, what do you think? 1,000 mice. Base, why'd you choose 0.5 for your base? Cut in half. So you guys see cut in half, you think 0.5. T divided by 5. Exactly. So I slipped back into some old notation from grade 10. I'm just going to label that as P of T. I'm not going to ding you guys if you just put P equals. But I want to be consistent with the notation I'm using. So P for population, T for time. And this is the last one we do. Anything else is really overkill. These are the same questions we did yesterday, just with the base being between 0 and 1. So 2 weeks. So note in this question here, since it's decreasing by half every 5 days, the time in our equation is days. So if you guys are looking for how many mice are left after 2 weeks, that's kind of the only way I can make these questions a bit more next level. You just have to make sure you're using the right units. 2 weeks is 14 days. And then the rest is just calculator work. Just do the exponent first. That is my advice to you. I'm not your dad, though. Do what you want. If you're good with brackets. But that would be 2.8. And I'll round to the nearest rat, even though maybe half of, or a mouse, even though half of a mouse might make sense, since the cats are like kind of killing them. Why did I put dollars? It's not dollars. It's mice. About 144 mice. You guys get that too? All right. So as I said, I think that's probably good enough. Anything else is just kind of overkill. You guys just need to practice. I'm going to end the video. See you later, YouTube.